Comparing functions graphically. When two graphs, say f and g, intersect at a common point or points, the x and y coordinates agree. At a point of intersection where x equals k, the function's values are equal. At x equals k, f of k equals g of k. So here we have the red graph, which is f of x equals x squared plus 4x, and we have g of x, the blue graph, and that's negative 2x squared minus 4x. So if we want to solve for x, we can just set these functions equal to each other, solve for x, and we see that x equals 0 or 3x plus 8 equals 0. So at the points x equals negative 8 over 3 or 0, that's where we have intersections. Solving inequalities using graphs requires that we look to find those x values where one function is positioned vertically above a second function. So here we have s of x equals x squared, we have I of x equals x, so we're going to solve for x, where x is greater than x squared. So the function I of x is greater in value than s of x at those x inputs where the graph of I of x is above the graph of s of x. So we have 0 to 1. So right here, from this point to this point, you see that the red line is above the blue line. So that's where this graph is larger than this graph. To compare average rates of change, we compare the values delta f over delta x equals f of b minus f of a over b minus a, and delta g over delta x equals g of b minus g of a over b minus a. So let's just look at these intervals and see on which intervals the average rate of change are the same for f and g. Let's begin with negative 2 to 1. So from here to here. So these are going to be our a and b values. This will be b and this will be a. So what we're going to do is find f of b, which is the f value, the y value right here at x equals 1. So that's 0, minus the y value at a, which is negative 3, over b, which is 1, minus a, which is negative 2. So here we have some double negatives. We have 0 minus negative 3, which is positive 3, 1 minus negative 2, which is 3, which equals 1. So the average rate of change for the blue graph between this point and this point is 1. Now, if we look at G right here, we see that it has the exact same points in that interval. So we are dealing with the same exact points. Therefore, this is going to have exactly the same rate of change, 1. And as you can see visually here, from this point to this point, the graph of G goes up 3 and over 3, and the graph of F also goes up 3 and over 3. So that's where we get that 3 over 3. So both graphs have the same average rate of change over this interval. Let's look at the next interval. So we have negative 1 and 1. So here, this is going to be our new a. I will erase these ones. Okay, so this is our new a, negative 1, and positive 1 is b. So over here, let's find f of b. So f of b is 0, minus f of a. So we go to a, and the f value is negative 4. Or the y value here, over b, which is 1, minus a, which is negative 1. So we have 4 over 2, which is 2. So for the blue graph, from here to here, the average rate of change is 2, because we're going up 4 and over 2. Now, for G, from those same exact x values, we are going from here to here. So we have a G of b, so that's 0, minus G of a, which is negative 2, over b, which is 1, minus negative 1, which is a, so that is 2 over 2, which is 1. So here you can see the average rates of change are different between f and g, so b is not right. I'm going to erase this to make a little room, and erase these. Alright, let's move on to c. So from negative 1 until 0. So we can see that's here to here, and that's also from here to here. So for f, we have f of b, so this is going to be a and that's b. So f of b is negative 3 minus f of a, which is negative 4, over b, which is 0, minus a, which is negative 1. So negative 3 plus 4 is 1. 0 minus minus 1 is positive 1. So we have an average rate of change of 1. You go up 1 and across 1, just like that. And for the g graph, g of b is negative 1 minus g of a, which is negative 2, over b minus a. So 0 minus negative 1. So we have negative 1 plus 2, which is 1. 0 minus minus 1 is 1. Look, also 1. We're going up 1 and across 1. So the average rate of change between these two graphs in this interval are the same. So C is correct. Finally, we have D. So let's do this one just using the graph visually without doing all of the math there on the algebra on the side. All right, so 0 to 1. So from here to here. On the red graph, that's from here to here. And on the blue graph, that's from here to here. Now you can see on the red graph, we go up 1 and over 1. But on the blue graph, we go up 3 and over 1. Therefore, the average rates of change are going to be different for those two graphs on that interval. The answer to this problem is A and C.